My name is Clement Huge, and I've been a database architect for the past 25 years. And I particularly shine with SQL Server. So I know that I believe the other sessions were more into MySQL and Postgres. So this way we can see a little bit of SQL Server here. I wanted to do this session because there are a little bit of unknown regarding filtered index. And there's a lot of companies that when they use SQL Server for their OLTP workloads, they have specific dashboard showing what is happening in real time, like the last events or the open transactions, and they have like little metrics on that. And usually clients call back to me and say, we have issues, it times out now. And the refresh rate is very low and everything. So the support team that watch the dashboard, they struggle, and we can see the CPU spike and so on and so on, and there's a snowball effect. And one of the quick solution and quick win is a filtered index. So I wanted to show this kind of workaround. So first of all, I wanted to tell what's a filter index. So it's similar to partial index on Postgres, if you know Postgres better. So SQL Server has been a flagship database engine for the past 1989, since 1988, and the filter index was introduced in 2008. And it appears on all editions from Express to Enterprise. And as you can see here, the syntax is very easy. It's like a normal B-tree index with the key columns and the include columns, but there's a where clause. And the goal of this index is just to make it a tiny index on a specific rows in the database. Specific rows like can be like like a table that is transactions table and the status equal 1, meaning the open transaction table. So as I see like the principle as an example here. They serve like specific queries to run in high frequency, and this avoid scans and key lookup costs because usually those indexes, they're so tiny that they can cover a lot of include columns. What are the limitations of filtered index? It only supports simple predicate. So in the where clause that I don't know if you remember, it's like where columns A equal value and or column B equal another value. Those are simple predicates. They go to equal, is null, superior, inferior, that's it. You cannot add like functions like date add or get date. You cannot also reference multiple tables, obviously, because it's an index on a specific table. You cannot use computed columns. So some of the tables you can have like computed columns or CLR-based data type, like hierarchy or geometry. Those are not available on filtered index. When you use parameterized query, which is most of the ORM, or when you use variables, then if you use, like, for example, I want the number of transactions that are open, and even if you have a filter index, it won't use this filter index if you use a variable. But if you use like the value itself, then it will use a filter index. So that's kind of a bummer because there's a lot of ORM that use parameterized query, and this can be a problem for like application code for that to use the filter index. So what next for the limitations? I would say that I can keep my hope high, even though I told Microsoft and filed bugs that maybe the parameterized query could work with filter index, because they introduced in 2022 like something called intelligent query processing algorithm with the query optimizer. And one of them is, for example, parameter sensitive optimization plan. And this actually defer the execution plan after reading the value of the parameter. So I would say if you can do that for this kind of improvement, optimization, then probably you can do that also on filtered index. But now what I wanted to show is like a workaround with a parameter as query and a workaround with a simple predicate. What if you wanted to only see the last day event? What if you wanted to see the last week event or something like that, like something that would use date add or get date or something like that? Is there a solution workaround? So how to remove the limitation on the date? For example, you want to give me the events for the last day. You cannot do create index where created date superior to date add day -1 get date, which is exactly what you want, but you can't because it has to be deterministic. It has to be a value. So how to remove this limitation? So you have no choice. You have to apply a date. So you apply like with YYY, MMDD, for example, to specify the day, but you have to schedule a daily refresh on the index every day, so that the filter index will not be fragmented because you rebuild it, will be fresh of the last day, and will be created very fast as it is actually covered by itself. So you can see the code on the right side to create the index that you schedule. You can see that you just use create index, and then you do a dynamic query to put the actual dates in character string, and then you execute it, and you do that every day, and it's super fast. Even though the table can be huge, this can run super fast because it just get the last day on, and it is covered when you do the query by the filter index that you created. The second limitation is the parameterized query. How to remove the parameterized query problem? Well, you either don't use parameters. So if you don't use parameters, it will work. It will use a filter index. But in some specific case, you would say, well, it's nice, but it could be tend to be a SQL injection. I want to make sure that my applications can still use variable. It's not the best way. So a solution to do that is to use a view that wrap around the filter index. What you can see on the code on the right side is how to refresh this specific view. So you can create or alter view with a dynamic query again that would just like put the same get date that you were putting on the index and create and alter the view on a daily basis as well. And this would create the view instantaneously and would be able to be used in your code so that when you use a parametered value, select the columns from the view where sent between a variable and a variable, for example, it would use the index, the filter index, and it would be very fast as well. What are the pros and cons on this solution workaround? So the pros are it's fast and a secure solution. The reason why it's fast is because it's using the same index on its own. So it's very fast to rebuild the index. It's never fragmented. It runs like in 1 or 2 seconds only, unless you have like a query that drag a little bit. The solution is also self-healing, so that's why it's secure. You're using the option drop existing when you create the index. If you can see on the code here, you use with online equal on if you are on enterprise edition or off, data compression equal page, but mainly like drop existing equal on. And the way the fact that you use drop existing equal on makes the solution self-healing. In case there is an error, it will go back, it will roll back the index to the previous state, which would be a fail safe. And then, you know, you have an alert, and then you fix the problem if you have a, you know, if you want the day. But even if you forget it and the next day the solution, is successful, then it's not a problem, because you just had for one day, like 2 days instead of 1 day. So it's not the end of the world. Why it can fail? In specific case, it can fail because it's a deadlock victim or something like that, or there was like a large query on it, and it was not able to rebuild the index, especially on the online equal off for the edition that are below the enterprise edition. The other advantage is the storage and the CPU savings, because obviously the index is very tiny compared to the data, to the table, and the savings on CPU and memory, because when you maintain the index or when you use the index, it will never really use that much CPU and memory to consume the index or to rebuild the index and to sort it and everything. You get savings as well a lot on CPU when you do the key lookup. Well, you actually don't do key lookup because all your columns are included mainly, because it's such a small index that it's okay. The negative is the small code change. As I said, like unfortunately, like parameterized query directly on the table would not work. So if you want to use parameter, then you need to use a filtered view. So you need to do a small code change. On the schedule job, you need also to change a little bit to put like the option quote identifier to on. Otherwise, it would not be able to rebuild the index with the dynamic SQL. And finally, and it makes sense, you need to do a monitoring of those schedules. So it adds a little bit. That's why I say it's a con, as it's not something that you can have the database engine to be performing on its own. But on SQL Server, we do a lot of adjustment of update statistics and rebuild index anyway. So it would just be an additional step to the schedule. So now I wanted to show you like in action. I have 14 minutes, which is nice. It's comfortable. I will present like the execution plan that I notice without the view, with parameters, with the filtered view. I will show you like how the jobs is scheduled, how it's built, and how the job durates, and how you can monitor the job. So here you are on a database that has the table, the famous table event, and you can see that the event table is extremely large. It's about 600, like shy of 600 million rows, and it takes about 170 gigabytes. And you can see the index are heavy as well. And they do have to perform like metrics on last day events. Just to show you like the way we can see the size of a table is by using SP space used. Let me increase the size so you can see it better. Then you can see this table as already like different indexes and the filter index last day sent. If you use the parameters, then and we will use the estimated execution plan, because this will run forever if I try to run it. It would do a cluster index scan and won't take the filter. It actually show you that there is a missing index. I'm not sure I can increase it. Unfortunately, I cannot increase the size. Hopefully you can see it. Let me remove that so that it's easier. And you can see that the scan on the entire table, and it estimates like 578 million rows to be scanned, and obviously this will take most of the cost of the execution plan. Now, if you don't use parameters values here and you directly use the values, let's say, for example, I want the last 2 hours, this is included in the index, and therefore it would use the filter index fix event last day event and estimate the number of rows by about 30,000 rows. So it does actually use the index. This time I can query it. So even though the table is very large, when you query it, it would just be instantaneous for the matrix, even though, and it would only do 198 logical reads, and that's it. Now, I'm not going to took it for a long time, but because we're on the read committed snapshot isolation, I can run it. I just show you that if I run this thing, it will run forever. Like I don't need to, after like 10 seconds, I will stop just to show you that it's not even worth that. And that's what's happening on the dashboard before. Now, we can see the storage of the event table. And you can see in the storage that indeed, most of the index are very large, like 40, 50 gigs, 70 gigs, 18 gigs, except the little filter index, which is very tiny, 37 megabytes, even though the table is 600 million rows shy. Just wanted to show as well how to build the schedule jobs. So the schedule jobs is now run by Cloud Run, so that's why it's disabled. But the way it was built here, if it opens, there's a step that refresh the view and then the step that create the index. So the step that refresh the view has to be done beforehand because you actually add one day. And if you refresh the index first, then suddenly your view cannot use the filter index because it's a 1 day, it's outside the range. So we do the view first like that. So we build like, I don't know if you remember in the presentation, we build like a view, a start procedures to refresh the view. And then we can run this quantity identifier on SQL expressions to build the index dynamically with the date of today. Then when you run it, it runs like super fast. Unless there's like a small little lock. But as you notice, it's very fast. And it took like about 2 seconds. And within those 2 seconds, you rebuild the index without any problem. So that's why it's not really a problem to use this solution. With another client, I use this solution and I built like about 15 filtered index on various different tables so that they can build their monitoring of the last day of all the counts of the orders, the transactions, and everything. Trying to make sure I can know. Here you go. And that's about it for me. We are 5 minutes shy, purposely in case there are any questions. Thank you.